Okay, so this is how to analyze a function when you're given it as an equation. This one looks particularly nasty, which is why I decided to go over it. And we're going to be going over the whole gambit from A to F. Although, actually, I should specify we're more going to go over from B to F. Because for part A, if you want to know if the point is on the graph, I do have a video specifically for that. It's going to be linked as a little card in the upper right of the video. So see video in upper right. The exact same process will work for this function. So I'm not going to spend time going over it in this video. Uh, okay, so for the next part, it's saying if x is equal to 1, what is f of x? And then you need to express your answer as a point. So all this is asking me to do is take 1 and plug it in for x. So all I'm going to do is everywhere I used to see an x, it's now going to get replaced by 1. So I'm going to very carefully write this out. And I'm going to zoom in just so it's a little easier to see. I have 18 on the top. Instead of x squared, it's going to be 1 squared. On the bottom, I see x to the 4th. That's going to be 1 to the 4th. And then plus 81. So now you just want to simplify this very carefully. I see 1 to the 4th over here. 1 raised to the 4th power is 1 times 1 times 1 times 1. And that's just going to give me 1. Very similar deal. 18 times 1 squared is just 18 times 1, which is just 18. Okay, so now I'm going to continue. I have 82 on the bottom and 18 on the top. However, if I typed this in, this would be incorrect because I have to simplify the fraction. Okay, so they're both even numbers on the top and bottom. So I'm going to divide by 2 on the top and bottom of the fraction to get 9 and 41. Okay, so this would be my output when I plug in 1. The way that I would express this as a point would be if I plug in 1, I receive out 9 over 41. So this is what it looks like as a coordinate pair. Okay, the next part. Sorry about that. Okay, the next part says, if f of x is equal to 1, what is x? So in other words, I don't know what my input is, but I know what I was supposed to get out. I'm supposed to get out 1. So the way I'm going to set this up is I'm going to say 1 is equal to the function I started with. So I'm going to say 18x squared, x to the 4th plus 81. Now, this is solvable by hand. I'm going to go through how to solve it by hand. If that's too confusing and you don't like to solve it by hand this way, this is doable on a graph. Okay, and I'll go over how to do that on a graph in just a second. But first off, I'm going to explain how to do this by hand. So I need to solve for x, but the problem is my x is trapped in this horrific amalgamation of letters and numbers. So what I'm first going to do is get rid of the fraction here. I don't like the fraction with the variables in it. So I'm going to multiply both sides of this equation by the denominator. So real quick, I'm going to copy paste this and make it overly clear what I'm going to do. So on the left side, I'm going to multiply by x to the 4th plus 81. This basically gets this out of the denominator over here because I have to do this on the other side as well. So actually, I'm going to highlight this red so it's a little clearer what I'm doing. And this is legal as long as I do it to both sides. Now, when I do it to both sides like this, it essentially cancels this denominator out. I don't have it anymore. So on the right side, I'm only going to be left with this 18x squared. Okay, and 1 times anything is just what I started with, so I don't need times 1, and I can leave this like that. Okay. Next thing I'm going to do is push all of my terms that have x's to the other side. And I'm going to write this in descending order, so it's going to seem like I kind of put them out of order. You could put the x squared back here, or you could put it to the front, as long as you remember to subtract it. So I'm doing basically minus 18x from both sides. Just to be a little more clear about that, I'm doing minus 18x squared. That cancels this out, and I'm doing basically minus 18. I'll put it over here. X squared on the other side as well. I'm just sandwiching it in the middle of the terms. Okay, and now This is actually factorable. It's going to be easier to recognize how to factor this if you do something called a U substitution. I'm going to say U is x squared. Now, that seems really awkward. Like, where did this come from? The short answer is there's no formula for this. You kind of, you'll get a sense for how to do this later, but we haven't properly done this. We haven't covered this in class yet, which is why I think the intended way to do this is actually graphically. But I'm going to make this substitution, which means everywhere I see an x squared, instead I'm going to rewrite it as u. So here I see x squared, it's going to be u instead. Over here I have x to the fourth, which this is really x squared squared. So this part right here, this x squared, that's going to get replaced by u. So it was a little confusing, but what I basically did was I rewrote this guy as x squared and then square it again. That is the same thing as x to the fourth. I'll draw that on the side here. So this guy right here, that is x squared squared. That doesn't look like a 2. And this guy in here, this is really u now. So that's where this line over here comes from. And now you can factor this using your usual methods, or you could use the quadratic formula in order to solve this. But I'm looking for numbers that multiply to 81, but add to negative 18. So that's going to end up being -9 and -9. So when I factor this, I'm going to get u minus 9 times u minus 9. Or in other words, I don't know why that's a different color. Or in other words, u minus 9 squared. And now I'm going to solve this for u. I know that seems a little awkward because I need x. I need to solve for x, but we'll get there, I promise. So I'm going to take the square root of both sides, and that's going to leave me with u minus 9 equals 0 when I take the square root of both sides. So that's what I'm going to draw here real quick. Square root, square root. Okay. And now finally, I'm going to do plus 9 to both sides. And I get u equals 9. So plus 9 here, plus 9 there. So I found an answer for u. But remember, I just invented u. U was not in the question anywhere, so that has no meaning for the answer to the question right now. So what I'm going to do is go backwards to x's. U is equal to x squared. So instead of u equals 9, what this really means is I have x squared equals 9. I'm using this substitution to go backwards the way I came. Now I can solve this for x. So similar deal before, to get rid of the square, I need to do the square root. So when I take the square root, I'm going to get x is equal to actually plus and minus 3. Because when I take the square root, I technically have a positive and negative answer. But the reason why it doesn't matter over here is because if I do square root of 0 plus minus, that's still just 0, right? Because you can't have a negative 0 and a positive 0. It's still just 0. So this plus and minus only really matters when you have a number that's not 0, because then you'll basically have 2 answers. But 0 is the exception where you'll get just the one answer. So my final answer is that x is plus or minus 3. Okay, so I mentioned that this is probably intended for you to be done on a graph because this algebra is pretty complicated and we haven't done anything like that yet. So I'm going to go ahead and show the graph real quick. For what x value is my output 1? And you can see that the two graphs connect right here and right here. And that is exactly what we found when we did this by hand. So I'm going to go ahead and add this screenshot into the document I was working on. We'll go to this one. And this is all I did. So I highly recommend using Desmos if you're doing this homework on your own. Obviously, you can't use this during exams, so just be mindful of that. You don't want to crutch on it too much. But you can see that we get the exact same answer either way. All I did was I graphed my original function, and I said f of x equals 1, because I'm supposed to find where that's the case. That's what the question asked me over here, if f of x equals 1. And now all I need to do is grab my x values. Wherever they intersect, I need the x values. By hand, I found that it was plus and minus 3, and you can also see that it's plus and minus 3 from the graph. But the graph took me 2 seconds, and the algebra took me forever. So use with caution. Okay, so now we're going to continue on. What is the domain of f? So remember, domain is everything that I'm allowed to plug in for x. I'm going to start by assuming my domain is all real numbers. Then my next step is I'm going to look for a fraction bar. Do I see a fraction bar? Yes, I do. So I want to make my denominator not equal to 0, because I know that if I make my denominator equal to 0, I have a problem. So I'm going to scroll all the way down here, ignoring this. I'm just going to collapse this. This is for a separate video. Okay, so for part D, I'm going to take my denominator, which was x to the 4th plus 81, and that's not allowed to be 0. If it equals 0, I have a problem. Okay, and now I'm going to go ahead and solve for x. All right, so I'm going to subtract 81 to the other side, and then I'm going to want to take the 4th root of both sides. Now it looks a little goofy, but the way that you take a 4th root, I'm going to go ahead and draw it here. Yeah, let me scroll down a bit. So it looks like a square root, but you just put a 4 kind of in the upper left corner. And I have to do that to both sides. But now the problem is when I take the 4th root, that is going to give me, actually, I don't even need to do this because this 4th root of a negative can't be done. So in other words, what this is telling me is I'm not getting any numbers for x that don't work. If I try to actually solve this for numbers that don't work, it gives me an error. So trying to solve for values I can't have for x gives me an error. This means I don't have any numbers that don't work. Everything is allowed. So even though I had a fraction bar, it didn't actually cause me any problems. In other words, my denominator is never going to equal 0. I don't have any problems to worry about. So my domain is all real numbers. Okay, up here. List the x-intercepts, if any, on the graph of f. So my x-intercepts are going to be places where my graph crosses the x-axis. And you can see just from the picture over here that it should be 0, 0, right? The way that you would officially solve this algebraically, so I'm going to put E here. That is not it. Okay. So the way that you would do this algebraically without using the graph is you would make your y equal to 0 and solve for x. So essentially, I'm going to be redoing what I did up here in part C, except instead of equal to 1, it's going to be equal to 0. And now I need to solve for x. So I'm going to copy paste this here and actually go through the solving process. And remember, the graph shows us that my answer should be 0, 0. So I'm looking to get an answer of 0. Same deal as before, where I'm going to get rid of this denominator by multiplying both sides by the denominator. So I'm going to multiply the left by this guy, and I'm going to multiply the right by that guy as well. So here. And this is also kind of nice, because when I do this, 0 times anything is just 0. So on the left over here, my left side is still just 0. But on the right, the denominator gets canceled away. So this is all I'm left with. The ugly fraction disappeared. Now what I'm going to do is divide both sides by 18. So divide by 18, divide by 18. And when I do that, I get x squared equals 0. Oops, sorry. Because anything 0 divided by anything is going to end up being 0 still. And now finally, I need to square root. So I'm going to get 0 equals x. So just like we thought, when I plug in 0 for x, it's going to give me 0 out for y. my intercept is 0, 0. So we saw that on the graph, and you can grab that right away. Or you could do this the long way with algebra. Okay, and finally, list the y-intercept if there is one of the graph of x. So the y-intercept, I'm going to figure it out the exact same way, except instead of setting y equal to 0 and solving for x, I'm going to plug in x equals 0 and solve for y, right? So same deal, except, whoopsie. I don't know what so you can leave it as f of x, or you could call it y. But I'm going to plug in 0 for x and see what comes out. So over here, I'm going to have 0 squared. Over here, it's going to be 0 to the 4th. So when I simplify this is going to be 81 on the bottom, but 0 squared is 0, and 18 times 0 is going to be 0. So this is 0 over 81, which is still equal to 0. So once again, I'm still getting the same point, 0, 0. So intercept, so let me see, x-intercept is this, and then y-intercept is also 0, 0. Once again, this is visible on the graph as well, right? So you can see the y-intercept would be where it crosses the y-axis, and it crosses the y-axis, boom, right there at the same point. So the point 0, 0 is both an x-intercept and a y-intercept. That's perfectly legal. And just to point out, I didn't need to go through all of that work necessarily because I found it basically in the previous question. I plug in 0 for x, I get out 0 for y, and that's really what I'm looking for. Okay. And that looks like everything. That hits all of the points except for A, which once again, check the video I have on how to see if a point is on a graph. All right.